Hello, everyone, and thank you for joining today's webinar, the third in a four-part CALGreen Embodied Carbon series, Implications of Material Procurement for Design Professionals, made in partnership with the CEOC Sustainable Design Committee. As you get settled, please feel free to say hello and where you're joining from in the chat. To qualify for continuing education credit, AIA California provides the learning objectives for every webinar and includes them in the PDF presentation that can be made available online. We will provide links in the chat box where you can find upcoming and on-demand climate action and ZNCD webinars from AIA California. A few quick housekeeping reminders. Today's session is being recorded and can be made available on the AIA California website, aiacalifornia.org. Today's session qualifies for one AIA HSW learning unit and 1 hour of ZNCD mandatory continuing education. For those who stay on and watch live, AIA California staff will report these units for you and will send you a ZNCD certificate of completion in the coming days. Please use the Q&A function to ask any questions for today's presenters. You can also like a question to move it to the top. Finally, cultivate a positive learning environment. AIA California strongly encourages attendees to be constructive in their comments and questions to the presenters and to one another to foster a positive learning experience for everyone. I'd now like to introduce our co-moderators for this CALGreen Embodied Carbon series. Luke Lombardi is the Senior Sustainability Consultant at Bureau Happold. He chairs the CEOC Sustainability Committee and is a co-lead of the CLF LA Hub. Avide Agigi is an Associate Principal and Sustainable Design Lead at ZGF. She also currently serves as the chair for AIA California's Embodied Carbon Working Group. Today we have Luke here with us, and thank you so much for moderating today's session. I'll hand it over to you.
Thank you, Sarah. And thank you to both AIA and CEOC for hosting these webinars. So here we are, part 3 of our 4-part series. Our past webinars, we've been talking about the overall framework of the CALGreen code. And last time we talked about a more comprehensive and how to meet compliance using the whole building LCA approach. Today, we're talking all about procurement and what it means from a material standpoint to meet the guidelines. So just a little bit of a refresher from the last couple of sessions. CALGreen is going to be starting July of this year, right around the corner, getting pretty exciting. It's going to be applying to buildings over 100,000 square feet, non-residential buildings, and schools over 50,000 square feet. And there will be 3 compliance pathways. So our first webinar was all about kind of an overview of the 3 pathways, and these subsequent webinars are more of a deep dive. So be sure to check those past recordings, and as well, all the resources that we've been sharing on these webinars will be saved there. In the first webinar, we got a lot of questions about what's covered, what's not covered. We continue to be developing resources with AIA and CEOC. And again, keep referencing those pages, and there's a lot of work behind the scenes and a lot of people pulling this information together. And last time we had a great group talking all about whole building LCA, which is a topic that is definitely growing in interest in the industry, and I think with this code will only get more and more important. We talked a lot about the reporting template required of that, and went through the whole process of how you include that in your drawings and specifications, and noting that that's required at permitting. Since we last spoke, there's been a CALGreen quick guide that was published. This outlines all the code language, provides the worksheets, is a really great resource. Sarah's gonna help us out and drop a link to that in the chat, I believe. And today we're gonna have a little bit different style here. It's a little bit more freeform. We have a really wonderful group of industry experts here. And we're going to be diving into procurement strategies for the materials that are included in CALGreen. And with procurement, it's largely about awareness and collaboration between the design team and construction teams. And in that light, we have a pretty big panel of industry experts trying to cover those different materials We have structural engineers like Salma, architects like Hafsa, Burt, and as well as folks on the construction side, Jesse Buckmaster and Sophie Pinetier, with a perspective on facades. And as well, I think a really important perspective from actual material manufacturers and suppliers from Dave Wright and Jim Little. And I will say, it's a big group here, and I'm not going to go into deep into bios, everyone's bios, and the event page. So be sure, check it out, and along with the other resources. And it's going to be a little bit more ad hoc discussion here. Lots of important perspectives to shed light on this topic. So the overview here, we're going to be going over a brief introduction on Buy Clean and how the framework of this CALGreen pathway came to be, and then talk a little bit about the collaboration needed between design team and the contractor, as well as upstream material manufacturers. And then we're going to do roughly like 5 to 10 minutes primers on each material. I'll note that I think each of these materials is deserving, and we could talk for a whole webinar, if not a whole day, about the nuances of them. But we're just going to get a quick overview of what causes emissions, how do we put these GWP limits into our specifications, and then share some examples from the group. And then hopefully we have a little bit of time at the end for some moderated discussion. And before we get started, again, there's this is a pretty big group, but we had even more folks who supported in discussions. Shout out to folks like Brendan Ray with NRMCA, Nate Forrest, CNCA, Max Putel with AISC, and many, many more folks, as well as folks who've developed resources on specifications. And there's a ton of great information out there, and we'll do our best to disseminate that to you all. So now we're going to get started. I'm going to hand it off to Salma Sayed, and have a go, Salma. Thank you.
Awesome. Yeah, thank you, Luke. So before we jump into the CALGreen requirements, I want to touch base a little bit on Buy Clean, because it kind of, I would call it a precursor to this third pathway for CALGreen. So you'll start to see the correlation. So Buy Clean is currently in effect for all public projects in California. It started in 2022, although it was first introduced in 2017. Its requirement got delayed because of COVID, but it's now being implemented for public projects since 2022. And the list of materials on this slide are all of the materials that are affected by Buy Clean. And so the maximum acceptable GWP, or global warming potential limits, that are shown on the right side of that table are the industry average GWP limits. So just wanted to point out, these are the affected materials, and they have to be within the industry average GWP in order to satisfy the Buy Clean requirements, and those are for all public projects. If you go to the next slide. One of the big differences between CALGreen and Buy Clean is that ready-mix concrete has been added to the list of affected materials. So you'll see everything else on this slide is the same as Buy Clean. In addition, we have ready-mixed concrete. And so for ready-mixed concrete, and we'll go into this much more in detail when Jim goes into detail on concrete, essentially ready-mixed concrete has a few little exceptions here in the code because it's a bit more complex than some of the other materials. And let's say you have 4 or 5 different concrete mixes on your project. CALGreen's prescriptive pathway allows you to take a weighted average of the impacts of all of those materials, or all of those different mixes rather, to be able to come up with one GWP number. So you're not necessarily looking at them in silos the way you are with the other materials, just by individual element. You're looking at them as concrete mixes as a whole on your project. Next slide. So we talked about Buy Clean requiring industry average GWP limits be met. For CALGreen, the mandatory requirement is 175% of the industry-wide average EPD limits. So 1.75 times the limits that were shown in the Buy Clean slide. So if I'm being honest, that's a really low bar. It's going to be very easy to meet those requirements to be within 75% more of the industry-wide average. So we suspect that this pathway is more of a record-keeping exercise than anything. Just we'll need to have EPDs that prove that all of our affected materials are being produced within this 175 industry average GWP limit. And so, once we have those EPDs, we don't suspect it to be very difficult to meet those requirements, but having those EPDs are going to be kind of the push for this pathway. So I've been saying EPDs a lot. I'm sure in the last few webinars, the phrase has been mentioned a bunch and probably introduced, but to give you a little bit of an overview of what EPDs or environmental product declarations are, they're essentially the way that we're able to quantify the impacts of our various materials on our projects. And so it looks very similar to a nutrition label. Looking at this, it looks almost identical. And if we were to use that metaphor, you could say that the declared unit could be maybe your serving size, and then you have all these different metrics. You have calories, fat, sugar, all sorts of stuff. We have that same condition here on our EPDs. We have all sorts of different impact categories, but CALGreen is focused specifically on GWP, global warming potential. So that's what we have boxed in red on the slide, and that's what we'll be primarily focusing on today. So other impact categories definitely are important to track and measure and be aware of, but at this time, the industry is really pushing to hone in on that global warming potential number. And if you go, yes, to the next slide, thank you. We won't talk too much about LCAs during this webinar because I know the previous webinar is pretty heavy on LCAs, but I just wanted to note that EPDs, essentially they measure cradle to gate emissions, which means those are the emissions associated with the product stage of a material's life. So from the time of material or raw material extraction through the time that that material leaves the factory gates. That's what the EPD is measuring. And then the EPD data essentially gets fed into LCA tools to be able to perform these studies that we do for, say, if you were following the performance-based pathway and doing a whole building LCA. So next slide. So there are two main types, I should say, of EPDs that we want to make you aware of. One being industry average, which we've said a few times, industry average EPDs versus product specific or factory specific, which we've kind of grouped into one kind of more granular type of EPD compared to industry average. So the industry average EPDs are developed by industry organizations like NRMCA or AISC, and they develop these EPDs by collecting data from their constituents and then sharing the average impacts associated with those various materials. Whereas the product or factory specific EPDs are published by the individual manufacturers for their specific products. And so in order to satisfy this prescriptive pathway of CALGreen, you will need all of your effective materials to basically have product or factory specific EPDs. So the industry average EPDs won't be acceptable. You'll need to have product or factory specific.
And I would add one thing here, a quick distinction, just following up from our webinar last time. I think it's really important to keep the two pathways separate, whole building LCA and the prescriptive, more like BioClean approach. And last time we talked a lot about reducing, getting to that 10% reduction by using low carbon product procurement. That is reduction from the baseline, from that average, and what Salma has been saying, that the threshold now for the prescriptive approach is a much higher number, much more conservative. We're not reducing from that higher number, that 175% average number. So just important to keep those two distinctions in mind. And with that, we'll transition to a bit of discussion about the responsibility of the design team, both structural engineers and architects, and again, requiring that there be some documentation, and there's similar to the whole building LCA approach, there's a worksheet that is to be filled out and included. And again, this is being done at permitting, right? It's being submitted with your permitting. And I wonder, Hafsa, if you could speak a bit more about this process and how you see it impacting architects and engineers.
Yeah, appreciate that. So happy to be here. Usually contract documents, as you know, consist of drawings and specifications, and sustainability requirements are covered in 018113 of the Division 1 in CSI format if you're doing specifications. And there, for those of us who have been doing LEED certification projects for years, know that all sustainability requirements like standards, if it has to qualify for South Coast Air Quality Management District for low emitting materials, et cetera, all references are included in part 1 of Division 1 of CSI. And including the action items, like what the contractor is required to do, if he's supposed to, if he or she is supposed to submit an action plan within 30 days of going into contract, what's the action plan for procuring these materials, and then what's the process of actually documenting that these materials were procured throughout the process, tied in with progress payments. So that's one. It's detailed. And then after that, Division 2 on, which is the technical divisions where concrete is, for instance, in Division 3, metals are in Division 5, all those reference standards and requirements will be kind of concisely added to those divisions, referencing Division 1 still. So when the general contractor hands it out to subs, they also know that they have to comply or provide these requirements, because sometimes they get missed if the general contractor isn't handing Division 1 to the subs. So it's a two-pronged process. This form, as we worked on it and it was developed, it goes in the sheets for the permitting official, but it's a two-pronged process. Specifications always take precedence if drawings are in conflict, so specifications need to be very tight. All the references, standards, everything has to be detailed and spelled out in Division 1, which is the general requirements. And a lot of us have been working on CALGreen compliance, and we know that low emitting materials and IAQ requirements are detailed, included in there, such as, VOC is mentioned in gallons per liter, just like the GWP limits. When we were pursuing low emitting materials, we would say it needs to be, for example, under 70 grams per liter for, say, an adhesive or the likes. So similarly, when in this case, it would be identifying that GWP limits, and they need to be under 175% for EPDs, and third-party certified. Also, for lead certification projects, we have been MRC2. If people have been pursuing, MRC2 credits, it is already asking for core and shell and interior materials and EPDs for those for credits. So it's a very similar process. It just needs to go in the sustainability requirements in Division 1 and be included. And the contractor has to come up with an action plan after going into contract. And then progress payments are directly linked to those, to his delivery.
So yeah, thanks, Hafsa. And so there's good precedent. We've already been doing some of this stuff. And I think this is a perfect place for Jesse to get your perspective as a contractor who's been implementing this, what you've seen. And, we have this line here drawn at permitting, but really what is a process and what sort of communication as the design team do we need to be having with you, and when should that be happening?
Yeah, thank you, Luke. So ideally, as a contractor, we're involved as early as possible. I know not every project delivery allows that, but please get your contractor involved. Design team, as you're coming up with your list of EPDs, there's a lot of input we can provide on, what suppliers and subs we're working with, products that are available. There might be additional products that have EPDs that weren't, on everyone's radar, because as much as we are responsible for procuring the products that have these EPDs that meet the CALGreen requirements, we are not the specifier. And so it's important to make sure that the products are being explicitly called out, so that we can procure the right products. We're going to go into a little bit in the steel and concrete, any challenges that might come up. There's a couple of products that, on speaking from experience with BuyClean, are pretty easy to get industry-wide EPDs. But when it comes to procurement for specific product-specific EPDs, it gets a little more challenging, especially on steel, which Dave will touch on a bit. And so we just want to make sure we're all on the same page early on, so that we don't have issues there. And then I think just understanding, having the design team set the expectations for how this information will be verified. I think a submittal process makes perfect sense. Having that in your Division 1 requirements, that there's a separate CALGreen EPD submittal, I think makes it very simple and straightforward to make sure that the contractor is providing the right materials there.
Excellent, thank you. Yeah, and let's get into it. Dave, let's start talking a little bit about steel and from a fabricator role, as someone who actually is purchasing these products.
Yeah, sure, Luke. Thank you. And I'll start by saying thanks for the opportunity to come speak about my favorite building material of choice, structural steel, here today to such a great audience. So I'm going to cover a handful of things in the next couple of slides and try to do it quickly. In general, start by just kind of talking through the two primary methods of that raw structural steel is produced these days by the mills. On the left of this chart, you see your traditional basic oxygen furnace or blast furnace, or otherwise known as an integrated mill. Been around for a few hundred years and been refined, but that's traditionally been the famous pictures you see of Steel City with the big chimneys and kind of putting off the emissions there, using large amounts of mined materials, raw materials, very large furnaces that are heated up with coal to produce very large quantities of structural steel. They typically have a very small amount, generally small amount of recycled content in them. And you see kind of down there toward the bottom, they, globally right now, they are still accounting for about 70% of the total raw steel, crude steel produced in the world. On the right-hand side of this is the more newer, really refined in the last, say, 100 years, the electric arc furnace, or the EAF method, also known as a mini mill. Those are traditionally using a very high content of recycled steel. So your bicycles, cars, washers, dryers, things such as that are going into these anywhere from 93 to 97% recycled content, with the other fill-in is the other alloys that are added to get to the right material grades and properties. You've got much less emissions that are being put out from these. Worldwide, it's talked about in the average of about 50% less CO2 emissions, but here in the US, it's actually more about 75% compared to its blast furnace counterpart. And then down there at the bottom, that note there that the global production is still around 70% for blast furnaces. That's changing. And here in the US, that 29%, I guess globally, that's made with EAF, that's all the way up to 70% and only going to be increasing, which is a great thing for the steel industry and for the design industry. Seeing even more and more investments being made by the large producers, such as, say, Nucor, just in the last couple of years has spent about $2 billion bringing on a very large plate mill on the East Coast that's going to be EAF and is going to make availability of those much greener and cleaner steels available to all. So if you want to go to the next slide. So as Jesse and Salma all talked before me, what can we do when specifying materials, considering discussing those as early as you can with your general contractor, your owner, your construction manager, and where possible, if the design team is able or the construction manager is able, is bring in and look at your local steel fabricators and suppliers in the area who might be most suited to bid on your project or to be supplying quotes for your project, and get their input as early as you can to help inform maybe writing those specifications. When you're looking at your project, we would recommend, from a steel perspective, really focusing on what is the primary materials that are made up in your structure. Are they primarily going to be your hot rolled sections, your wide flange, your channels, your angles, or is it going to be a predominantly HSS or tube or pipe type project with a lot of hollow shapes, and similar if you got a job with a lot of plates? Really understanding those kind of content is important, because of when we talk in a minute about how many mills are out there right now in the US that are producing with the EAF and that have facility specific or mill specific EPDs. That's another name for what Salma was describing there and what Luke had described as like material specific, but that term mill specific or facility specific, that's what we're looking for. And you're going to see that certain things like hot rolled sections here in the US, the industry has responded well, and there's facility specific EPDs for pretty much all the big providers. Whereas on steel plate and hollow sections, there's maybe lesser quantity of the mills that have been able to obtain their facility-specific EPDs yet. So taking that into consideration, and then even when you're reviewing an EPD, let's say a facility-specific, you also want to kind of look to verify if the information is being reported as fabricated versus unfabricated, because depending on how that EPD was created, it kind of tells you which of the different information between modules A1 to A3 that you need to be looking at when evaluating your the GWP limits. As far as some resources that are out there for designers and contractors that we recommend, the AISC has done a fantastic job over the last several years in helping drive sustainability and help lead with that. So they've got a whole section of their website kind of dedicated with really great links. They've done a fantastic job of linking to not only all of the industry average EPDs, but for this group today, what we're talking about is facility specific. So they've got a breakdown in all of the three primary structural categories here with hot rolled shapes, the hollow sections, and the plate that not only take you directly to the different mills that have the facility specific EPDs, but also have a note of the ones that aren't available at this time. So it makes it really easy to find in one central location, and they're doing a great job of continually updating that information. They also have some information for design professionals of some guidance toward writing those specifications for sustainability. And also they've provided links to the Code of Standard Practice. And I mention that because it does a great job of outlining what is truly defined as structural steel by the code, as well as just importantly, what isn't. You know, maybe things like grading or handrails where a client or design team might not be sure if those items need to meet. The AISC has a great, very detailed listing of what should and should not be considered. And then there on the upper right, you see the kind of a draft section and some recommendation on language that could be included in a Division 5 spec. And as Hafsa mentioned, you're going to have a dedicated sustainability specification in your Division 1. And then there in the lower right-hand corner is a repeat of what Luke had mentioned. These are the mandatory limits with the new upcoming CALGreen that's going to be going into effect, which are the 175% of the industry average. So if you want to go, I guess one other quick point I would say is there was a mentioned earlier in the slide, I don't know if it got talked about, but with the upcoming CALGreen, there's also going to be the Tier 1 and the Tier 2 that would offer some reduction from the mandatory. I think it was 15% for Tier 1, and I believe it was maybe industry average for Tier 2. I would bring that up, that's really important to discuss. And if you've got an owner or design team that's willing or wanting to look at that for their steel, maybe get in some open dialogue with your providers and see before just maybe mandating a Tier 2 across the board, what could you look at? Maybe a Tier 2 on the things are going to be able to be achieved, like say the hot rolled sections, which might make up the majority of the steel weight on your project, and maybe favor the mandatory or the Tier 1 for some of those things like plates that might not have a large quantity and may still be less competition, if you will, out there between mills that can provide a facility specific EPD versus those that can't. So next slide. So we were asked to, maybe provide an example, a short case study on a project that we've been working on. And while CALGreen has not gone into effect, the Buy Clean California did go into effect July 1st, 2 years ago. And this job, UCSD Triton Center down in San Diego, a new structure or a new project with, I think, 5 total buildings, the parking garage, 3 steel frame buildings and 1 concrete building. We were fortunate to be awarded last fall 2 of the larger buildings, steel frame. All the materials, because it is one of the University of California schools, do require to meet the full Buy Clean California. Roughly about 300,000 square feet in total of new structure, with I think about 200,000 fallen into the buildings that we're providing, with about 1,400 tons of steel. Noted the lateral systems there. It's a combination of concrete shear walls, BRBs, and special moment frames with RBS. But what I wanted to point out, maybe if we go to the next slide to kind of finish up, is that this is a picture of both of the 2 primary steel buildings, the 5-story and the 3-story. And we color coded these to kind of make it stand out that all of the hot rolled structural sections, so angles, channels, and wide flange, are in blue, with green being the hollowed shapes and kind of that orange or yellowish color being the flat plate. And as you can see here visually, the lion's share of the steel in these jobs is in that hot rolled sections. And again, no real challenges there when you're ordering in bulk from the mills, placing orders and being able to meet those Buy Clean California requirements. But where we really got into some challenges in this job is going to be those smaller quantities, the smaller plates, plates that are used as shear tabs and stiffeners. Normally those items, there's not enough on your job where you're going to a mill and you're placing a mill order for new material. You're typically partnering with your service center and local warehouses to obtain those smaller quantities. And until the industry kind of flushes out any at these warehouse and service centers, and where they're not bringing in steel anymore that doesn't meet, say, Buy Clean California, or doesn't have to be facility specific EPD, you're really at the kind of the mercy of what those service centers have. And so you're kind of playing the game of our steel purchasing agents, after being awarded a job, are having to call up and verify, what do you have on hand, and can you send me the MTR so we can go backtrack and see if that was produced at a place and a time that had a facility specific EPD. So just some lessons learned on the Buy Clean, and but I think the upcoming CALGreen will offer some relief to that on those smaller quantities, and hopeful kind of improved flow when it comes to those smaller quantities.
Thanks so much, Dave. Yeah, I think a really important narrative there. But just we're very limited on time, but I would love to get Jesse's perspective. 30 seconds, Jesse, if you can, on the contractor side, and when timing and when you expect to kind of need those advanced mill orders in.
Yeah, I think it's going to be really important to make sure that, again, these conversations are happening early, that we might need to make steel an early procurement item so that we can ensure that we're sourcing properly and we're getting the right information to the supplier so that they can track down everything they need to that's going to have the proper fees. And so, whether it's however your contract is set up, making sure as a design team that you're getting your contractor on board, letting your owner know that the contractor needs to work on this procurement, so that, again, we can all be on the same page. It's going to be really critical. Communicating those
Expectations early. Yeah, great. Okay. On to the next material. Jim, you're up, and thank you. I know it's a busy day for Jim, so appreciate your time and perspective on this.
Yeah, thank you, Luke. And I think it's a busy day for everyone, but certainly an important topic. So we've heard a little bit about it from Dave, and certainly from Jesse about the early collaboration. And as a ready mix concrete supplier, I think that's extremely important, as the capabilities of suppliers throughout the state, from north to south, the east side to the desert east side to the coastal west side, ready mix suppliers throughout the entire state and country have a wide variety, a wide range of capabilities, from materials, the sand and gravel that they use, the chemical admixtures that they use, the cement that they use, and supplemental cementitious materials. So all of those have a huge impact on what a supplier is going to be capable of doing. With the cement providing the highest contribution of global warming potential to a concrete mixture, that's an important aspect to look at, and so that's where a bulk of the emissions come from, is from that pyro process where we take the limestone and we fire that in a kiln. So we have to have lots of energy to process that limestone to reach those high temperatures. And then the chemical reaction that takes place between the limestone, where the CO2 is then emitted. So That's a bulk of the emissions produced in the cement making process, and that trickles down to a bulk of the emissions in the concrete. So this is just a little schematic here of the cement manufacturing process, where the material, the limestone, is fed in. Takes about 40% or about 40% of the emissions come from the fuels that are used. Different cement manufacturing facilities have different options when it comes to fuels, whether they're renewable sources or fossil fuels, or a combination of both. And then that process fuel is something that we can control from the standpoint of how much clinker is the clinker content of the cement utilized. So typical type 2, type 5 cement that we use here in California is roughly 90% clinker, 5% gypsum, and 5% limestone, going to be plus or minus. When we start talking different types of cements, blended cements meeting ASTM C595, such as type 1 Portland limestone cement, those can be lower by up to 10%. So they may have a 15% limestone addition, which would give you an overall 80% or so clinker content. So there's a big benefit right off the bat from looking at different types of cements, blended cements, and that sort of thing. So I think when it comes to the code, the Buy Clean code, as discussed earlier, the limits are pretty generous. And so I think it's real important to look at the intent of the code. And the intent is to select a product that has a lower GWP impact. So, and I think if the intent is really the key focus there, some good things can really happen. The great thing about concrete is that it is very dynamic, and we have lots of different options from various classes, from controlled low strength materials up to 10 and 12,000 psi concrete. So the ability to be able to look at concrete as a whole using a weighted average calculation is a very beneficial option for us. And this is some of the code language here. I do have some examples of what that may look like, but it does give you that option to use the weighted option. And that really helps, especially on the construction side, where maybe perhaps there's elements that really need high strengths early on. And oftentimes when we do that, the GWP of the concrete mixtures are really quite elevated. Or the other side of that is if there's a specific lower water cement ratio required, that has the tendency to increase the global warming potential as well, as generally speaking, you will be using concrete mixtures with higher cement or cementitious materials. So in the product GWP limit, it classifies the concrete by product category with the strengths as you see on your screen now, with the GWP values as listed. There are two different tables, one for what I will call ordinary concrete and the other for lightweight concrete. In general, lightweight concrete, there's some natural lightweight materials, but there's also expanded shale clays and slates, which are pyroprocessed and do have a tendency to have higher GWPs. In addition to that, in general, most lightweight concretes will have air, as air is the lightest thing we can put in there. And when we add air to concrete, it has a tendency to make it a little weaker. So we compensate with additional cement or cementitious materials. The other thing to note is that the table, the product category table goes up to 6,500 PSI and greater. So as we see more 8, 10, 12,000 PSI concretes, they'll fall in that 6,500 PSI or greater table. Yeah, here is.
Yeah.
Yeah,
Selma,
go ahead,
do
Luke.
you mind hopping in and talking a little bit about specifications? Thanks, Jim.
Yeah, sure thing. And I'm going to basically piggyback off of everything that Jim just said because he touched on a bunch of really good points here. But in summary, concrete is incredibly complicated when it comes to the different elements that go into the mixes. You know, structural engineers will need different requirements from their mixes. And we just try to encourage everybody at our firm, at least, to be as performance-based as possible when writing specifications. So really just putting in our mixed design tables exactly what we need for our concrete to perform structurally, and then letting the mixed designers have the freedom that they need to be able to meet those requirements, given, you know, all the different conditions, all the different storage capabilities, the different SCMs available in different regions. There are so many different factors that come into play with concrete, but we try to really discourage just putting in a lot of prescriptive values in your mixed design table if you don't necessarily need to specify them for your structural design. So this is on the slide, this is a table that's kind of screenshotted from a general template that has this performance-based concrete mixed design table, as well as an example of GWP weighted average compliance calculation. And so I believe there's a link on this slide to where to download that. That's free for download and for use for anybody who might need it.
And I'll say this again, just to reiterate, the limits now are very conservative. There's a lot of flexibility given to concrete, and this is really just a starting point to Jim's point around conversation and really engaging local ready-mix suppliers who know best how to reduce global warming content in their mixes. And Jim, if we we're very tight on time, so if you could do, there's some great resources.
Run through this really quick.
Yeah,
This is a project that is actually ongoing now, and the section in blue is the CALGreen requirement. At the very bottom right-hand corner, you can see that this particular project at this stage is 66% below the CALGreen limits, and it's about 11.5% the local CLF Pacific Southwest regional benchmarks. And then so that's a great example to compare a project with CALGreen and with CLF. So you can see there's lots of room there in the CALGreen, but again, get back to the intent of the code. You know, is to select a lower GWP product. Next slide.
Yeah, and similar, and
I'll just similar fashion here. You know, same thing here. This particular project is almost 75% below the CALGreen. Again, this is looking at the product on a weighted average, and then the other lower number in the bottom in yellow, 22.7, is the CLF below benchmarks.
Yeah, and there are lots of great resources by Interim CA. There's a calculator to do this weighted average, as well as other guidance from folks like Central Concrete in the Bay Area who've good guidance on performance-based specifications. So links at the end, and next up to Sophie to talk about enclosure and related materials.
Yeah, thanks for having me today. And I'm bringing some insights from a pleasure facade constructor point of view. So I'll provide insight from the LCA compliance path, after which I will provide some performance compliance path observations. So from an LCA standpoint, most of the projects I've seen, and potentially don't represent all your project, but what I've seen, the facade is roughly a quarter of the carbon footprint. And so in this specific slide that you see on your screen, which is not a project I worked on, but one provided by Atelier 10, who did this LC analysis for the COB3 projects designed by SOM. They also show that the facade is about a quarter of your embodied carbon footprint, whereas the structure for this steel specific building here and together with its concrete basement represents 50 to 60%. So as we move to the next slide, we have to remind ourselves when we do an LCF for an entire building and compare it to this baseline that facades are highly dynamic from a procurement standpoint, and specifically for glass, as we will also see it in a second. It's a broad supply chain geographically. And on the left-hand side, you might see, for instance, for glass, in red, this little markers on the map developed by the NGA, the National Glass Association, on this website, which is linked here, shows the float lines where the glass is, melted and produced in large, 10, 20 feet sheets, and then is then sent out to these blue little locations that are those processing facilities where the glass is going to be cut down to size, the edges are going to be polished, which is important for strength of glass. The glass is going to be tempered, laminated, coated, etc. So, historically, the facade procurements in your decision process has been driven by, schedule, budget, warranties, and it's going to be needed to be bent. This very optimized supply chain needs to be bent to accommodate carbon considerations. So there's certainly an adjustment there in a way designers are going to be engaging with contractors in order to develop the low carbon solutions. And it takes, as Jesse, Luke and everybody here insisted, early collaboration and being discussing about those things before they find themselves into specifications so that there's a high level of success for the solutions envisioned. And then to the right-hand side of this diagram is a diagram from an article pulled together with Laura Carnath and myself. We published this in 2022 that shows that even for building in California, your optimal supply chain approach extends far beyond California for the specific systems, and that article also includes consideration from the work done with Isabel Hans now at Atelier 10 that showed that transportation of those materials into California market are in the ballpark of 10% of the emissions of the curtain wall that we have studied in the research. Again, not necessarily representative of your project, but the goal here is to provide you with this kind of hotspot and understanding of what matters when you do your LCA. So what matters is going to be the materials themselves that can represent the lion's share, again, of the emissions. So if we zoom into the next slides and specifically to the glass that is covered by BCCS/CALGreen, it is paramount for designers to understand how glass or materials in general are produced. So architectural glass, it's, as you can see here on the screen, is typically produced on a float line where raw materials are melted to produce those large 8 by 10 up to 20 feet large sheets of glass that are at the end of this diagram that you see here. Those pieces are then sent to the producer, again, that's going to cut down those those sheets and put them through the various processing steps that I just mentioned, and that are actually excluded from what qualifies to be under the performance requirements of the BCCS/CALGreen. And so for some glass products, these specific, floating operation like flat glass, what is defined by those boundaries of what defines flat glass, can represent 60 to 80% of the total carbon footprint of your material. So if you just shift back to LCA mindset, it is still a very valid point of reference, because even your super fancy coated, triple laminated, heat strengthened glass, it's still a lion's share of the carbon footprint comes from this flat glass approach. So that has informed the two pathways, the mindset of looking at your emission as a total, LCA approach, but also the performance path. So if we go to the next slide, we see what defines under the performance path, what defines a flat glass. So it's kind of narrow at this point. This is the current state of the code, and obviously it's dynamic, it's changing. It defines at the flat glass defines as float or rolled glass that is clear tinted, either installed by itself or part of a window. So even if your flat glass is within an IGU for some reason, that would need to be compliant. Processed glass, which is all those elements that I've mentioned, tempered, coated, laminated, is out of scope of the BCCS/CALGreen. And so the NGA, the National Glass Association, has developed those documents that can help your conversations with your local authority having jurisdictions in order to define clearly what qualifies or does not qualify as flat glass in your project. And so it's a new process. It's quite recent. It is informed by, you know, where emissions come from, but there's still a little bit of language that needs to be tuned up and to be discussed with your local authorities having jurisdictions. And so that's very important that you reach out to both the suppliers, jurisdictions, and also the associations that are there to support you. So in the next slide, you see what the association, the NGA, has pulled together to issue the flat glass EPD. So that again is an industry average EPD. It is not acceptable as a BCCS/CALGreen submittal, but it is what has informed the industry average threshold, the baseline of what is the average of the industry. And you see here, if you flip through these specific EPD, that the 1.3 figure is the average. And if you look into what's required into the next slide, thank you, to meet within your mandatory pathway of compliance, just the first step, the mandatory step, is extremely generous, as my co-panelists were saying, 75%. So we went from 1.4 to 2.5, except if you find yourself in a project where the goal is to go closer to average. So if you go to the next slide.
And I'll just add one quick plug here, is that those higher tiers are ways to indicate what the future will be. So this is a starting point and a framework to work from. And those, we can all expect that those limits be reduced in the future, but this is how we have to start somewhere, right?
Yeah, absolutely. And there are resources to see you where the industry has been historically. This is a document from the CLF that is based on 2022 data. Again, like the NGA EPD is expiring in 2024. It's expiring quite soon. We'll talk in a second. This is the same for insulation. And so these documents gives you, you may want to talk to your contractors and see if there's actually a few more data points. But the gist of it, to go quick, is that generally there are a lot of options for you to meet the requirements even under industry average. So if you go to the next slides, like here is the approach. Like, look at your compliance pathways. Is it going to be LCA or prescriptive? Second, look into what qualifies under the prescriptive path. Your glass, if it has been processed, will not need to comply. If nut 3 is make sure that if it needs to comply, if it's an IGU, it has still to comply. It's just the nature of the flat glass. And finally, once you've gone through all those checks, you can reach out to source database that are going to be provided to you shortly in this presentation, or talk to your producers of imminent EPDs to come of work they'll be doing. You want to have time for insulation. Let's talk about insulation. Feel free to reach out. There's a lot to cover. So for insulation, maybe in a minute to be quick, I know we're short. This is what I tell to my students. I say, most of the emissions come from when materials are in the oven, right? When things are baking is when most of the emissions are still today captured for those materials. So for mineral wool, it's going to be just the same. So next slide is the thresholds you have to comply with, and same as glass, these are extremely generous. And so in the next slides, you can see that for similarly to what I said for glass, the CLF is providing a lot of resources for light density, and in the next slide, high density insulations. So there are, again, a lot of major producers, but also plethora of products that are complying with the thresholds. So my last slide for insulation really recapitulate this pathway or flowchart of approach for the material of insulation, which is, again, look at what is the compliance. Do you have an LCA approach? Do you have a prescriptive EPD approach? Look also at comparing, if you do so, materials that have the same PCRs. Make sure the PCR is under the BCCA and CALGreen requirements, and make sure it has this type 3 facility or product specific APD requirements. That's a quick way to go at it. I'm sure there will be some questions. Thanks.
Thank you so much, Sophie. No, it's fantastic. And actually, before we hop on, I don't know if Jesse or Hafsa, if there are any other aspects from the facade, you briefly want to flag to the group before we move on. Otherwise, we will wrap up with the resources.
Oh, so we only have 5 minutes left. I did try to answer a lot of these questions. I think Michael Elia had a lot of questions for specifications where the language goes. So I just suggest look at those, and then I'll let you wrap up with any last minute resources.
Great. And I will say, the Q&A, like the previous webinars, really important to get those questions. And obviously, we're optimists on the panel here, and covered a lot of great content, but aren't going to have much time for Q&A. But we will track those questions, and we continue to develop resources for this. And Jesse, is there anything else you want to add there? I just to give you the opportunity. Okay, great. We're just going to close things up here with a few resources, and just share one tool that is really helpful when looking at these different materials and what products are available, and that's the EC3 tool. It's a free tool, database of EPDs, and I think we'll have to have probably a whole, also a technical webinar on how to use this, as well as some tips and tricks, but definitely recommend folks look at that to see what products are available. And then we've also compiled a really fantastic list of resources, and would just encourage folks, it can be a lot of information, and I think the one important piece of this is really all about kind of awareness and connection, and just talking about this. And I am certainly extremely grateful to all the panelists here who I've known or met through Embodied Carbon stuff, and definitely find it gratifying to learn about where our materials come from, and am really excited about the steps that have already been taken. I think this, in particular, the BioClean and CALGreen procurement or prescriptive approach, is already an indicator to the industry for folks like National or Nucor to invest in a future where their manufacturing processes are decarbonized. And it's also very exciting to see just last week that there's a lot of funding from the DOE, $500 million to National, and I think it was like $6 billion overall, something like that, just to drive down these emissions and continue to move the needle. So with that, Sarah, I don't know if there's maybe any closing remarks, and then we can perhaps take a couple questions. I feel like, yeah, a lot of content to cover. We'll definitely go in more depth in the future, but anything you got, Sarah?
Yeah, I just wanted to echo what you said. Thank you to all of our amazing panelists today, really doing a super speed run on all of these things, as Luke, as you mentioned, that could have their own webinar. And so definitely your guys' feedback, the attendees' feedback on today's presentation can help inform us on future programs to make sure everybody feels comfortable with the new CALGreen embodied carbon measures going into effect July 1st, 2024. And personally, again, sincerest apologies for those who are experiencing Zoom technical issues. That hasn't happened to that capacity before, so we will do our best to look into that. So super sorry. I know most of you had already reached out to me, but if you have any questions about that, or you're standing for today's program, please feel free to email me and I will do my best to help you out. And yeah, we have another program, the final in this 4-part CALGreen Embodied Carbon series, focused on the other compliance pathway for adaptive reuse, which will be really exciting. That program will be on June 12th. More information on that program will be sent either in a follow-up email or another webinar correspondence that you'll see from AIA California and from CEOC as well. So thank you guys again so much. And that's all I have from me today. Z&CD certificates will also be sent. So keep an eye out for those in your inboxes as well.
And there will be a recording of this posted, and we also take these questions, which yeah, we certainly can't address all questions in 60 seconds. So I think we leave it there, and thank you so much for everyone for joining, and particularly this panel, amongst many other folks who are engaged on the topic. So thank you.
Thank you, everyone. Have a great day.
Thanks, everyone.